I'm telling you the strategy. We know the straight line gradient is the angle it makes with the x-axis. Tangent of this angle is called the gradient of a straight line. For this purpose, I'm going to extend this x-axis, and two tangents are given for two curves. One curve is here. I'm going to extend this line, which suppose it makes angle here with the x-axis theta 1, and another straight line is tangent also. Tangent, if I extend, suppose it makes an angle with x-axis with the angle theta 2. So if I consider this triangle, total triangle from here to there, alpha is the angle between these two tangents. So alternatively we also can write here alpha, and we know that exterior angle in a triangle which is theta 1 equals to, we can write theta 2 plus alpha. So if I define alpha from here, we can write alpha equals to theta 1 minus theta 2. This is the strategy we are going to apply here. So what is the theta 1? Theta 1 actually the tangent, this is the tangent it makes. Suppose if I consider this is the tangent 1, and that is the tangent equation 2. The tangent 1 makes an angle theta with the x-axis. So gradient, if I consider of this tangent is a m1, then we can write actually m1 equals to tan theta 1. If the gradient of the line I have drawn, it makes theta 2, which is tangent 2. If I consider the gradient is 2, then its definition actually tan theta 2. This is the actual gradient definition. We need to apply this formula here. Let's start our journey. So for m1 gradient, it makes at the point where q, 2 and 3, and its equation is given y equals to this. We are going to write the equation y equals to half x square plus 1, which the curve given below. Another curve equation which is y equals to 4x plus 1 to the power half. We're going to find out the gradient from these two tangents. So if we differentiate this one divided by dx, it gives us half into 2x, which is x. And if we differentiate the curve given above divided by dx, it gives us half into 4x plus 1, half minus 1, which is minus half, and coefficient of x we need to multiply. Here coefficient of x is 4, so we have to multiply with the 4 here. So we can cut out this 2, and finally we got from here 2 divided by 4x plus 1 to the power half. So what is our m2 now? We can write here m2 here. m2 is gradient of the first line. This is the first one, tangent 2 we can say, which I defined with the m2. It gives us, we are going to put here the x value 2 and 3. x is 2, so let me put our value of x when x equals to 2. So gradient 4 into 2 plus 1 divided by half, and it gives us 4 to the 8 plus 1 9, square root of 9 is half, so 2 by 3. We got it when I put the value when x equals to 2. For the second one, if I consider gradient is 1, then at the point x equals to 2 we got the gradient. So we are going to put here the value x equals to 2 directly. We got the gradient 2. Now it's very simple. We already defined our definition for alpha, theta 1 minus theta 2, so easily can find out to alpha. And m is actually m1 is, this is tan theta 1 according to the definition. 2 by 3 is, we can write here tan theta 2. So alpha, if we define, this is actually coming here, if we make theta 2 as a subject, which you can write here tan theta 1 minus theta 2, which is tan inverse 2, and then another one tan inverse 2 by 3. Now only the working we need to apply calculator working, which you can write here. I'm going to show calculator. Yes, this is our calculator. So tan inverse shift tan to close the bracket minus shift tan 2 by 3, close the bracket, and we got the angle which is 29.7 degrees. So let me write 29.7 degree. It is written here T significant figure, so this is our T significant angle, and that is our answer. Hope guys you would understand from here. Actually you have to solve this question according to the rule of definition of the tangent of a straight line. So two tangents makes an angle alpha here. Tangle definition, gradient of a line, gradient of a straight line definition is it what the angle it makes with the x-axis. Gradient of this angle, tangent of this angle is called the gradient. Tangent of this theta 1 is called the gradient for the first tangent equation m1 we defined, and another one theta 2 it makes the second tangent equation which makes with the x-axis theta 2. Tangent of this theta 2 is called the gradient of this equation, tangent equation of the I marked with the tangent 2 and tangent 1. So that difference, angle difference, is called the alpha, and we did the same thing. So this is the definition. I think second part here is very familiar with you. Find by integration the area of the shaded region is one of the common question. We did the first one here, and second one I'm going to show it on here on the left side. Integration by finding the area, we can do one thing. Let me erase some part that because no relation with this question and the area under the curve. Bounded area is here. Say we have to define which one is given above. So this is the curve given above, that is the curve given below, and both of them intersect at the point when x equals to 0, and another point which is x equals to 2. So we have to put the first curve, the above one first, which is 4x plus 1 to the power half. Then the curve written below, which is minus half x square plus 1, and total things we have to integrate from left side to right side, which is limit is given here from 0 to 2. This is our strategy to do this question. If we can do this integration correctly, we will get the answer definitely. Area under the curve above 1 we tilt to the x-axis minus the area under the curve lower curve tilt to the x-axis given as the area bounded by these two curves. This is our strategy. So we are going to integrate this one. We know the strategy of integration here, 4x plus 1 to the power half plus 1, which is 3 by 2. Let me write 3 by 2. Power is goes to the divide with the 3 by 2, so we can write here 2 by 3 as well, because 1 by 3 by 2 is 2 by 3, and coefficient of x we got from here 4, so we have to multiply 1 by 4. This is the integration of the first part minus the second part integration, which is half into x 3 divided by 3. Then another part is 1. If you integrate, we got the x. Integration done. We are going to put the limit 2 and 0. Let us simplify this one. It gives us 2, so which is 1 by 6, and inside is 4x plus 1 to the power 3 by 2, and the last part is We can remove the bracket, no need. We also can write directly 1 by 6 x to the power 3 plus x. We have to put our value 2 here and 0 here. If we put here 2, it gives us 1 by 6. 4 2 is the 9, 4 into 2 plus 1 to the power 3 by 2, first one, minus 1 by 6 into 2 cube plus 2, then minus the inter thing, we have to put the 0. Only the value take place if we put here 0, which gives us 1 by 6. If we put here 0 0 plus 1 to the power 3 by 2, and other two values actually from here, if we put here 0, it gives us plus, this is 0, that is also 0, so plus 0 you can write. So this is our simplification part. We have to add this value and find out the answer, final answer, which is it gives us 4 to the 8 plus 1 9, square root of 9 is 3 is 27, so you can write 27 by 6 from the first part we got. Then another thing, minus 8 by 6, I think minus 8 by 6, then minus 2 I wrote here, and the last one is 1, so minus 1 by 6, minus 1 by 6. Now we can use our calculator to get the answer from here. This is one thing is 27 by 6, then minus 8 by 6, then minus 2, last one is minus 1 by 6. Let us use calculator now. Okay, can put our calculator here and calculate from here, which is 27 by 6. Next one is minus 8 by 6, then minus 2, then last one is minus 1 over 6. Okay, calculate, and it gives us only 1 is our answer. So we can write here unit square, because it's the area bounded by 2 curves. This is the total working of this question. Hope guys you understood this. Thanks for watching.